Yeah, guys, we are going to start in a minute. Hi, everyone. Welcome to Spark Demo. Okay. Yeah, we are going to start now. Myself, Janardhan. I am the trainer. I am working as a data scientist in an MNC. I am former employee of TCS. I have 9 years of experience, and as a data scientist and Hadoop big data, have been working on more than 4 years into different companies. So, sharing or teaching to people is my passion. So I am doing it on weekends and weekdays and all those things. So when it comes to my teaching profession, I have been teaching from last 3 years in mainly big data Hadoop and NoSQL databases. So that is a small intro about me. So I just go through the agenda, and I just want to know how many people are already working in Hadoop. So just ping in chat box, you people can ping yes or no. How many people are working on Hadoop already, and how many are directly just new to? Yeah. Okay. Yeah. So it is 50-50 kind of thing. Some people are working, some people are new. Yeah, good. So is it audible to everyone? Some guys has some problems. Any yes? Can any one or two guys confirm? My audio is yeah. Okay. So I think some problem is there from their end. Okay, no issues. Those who can't hear, they can please rejoin. Problem will get resolved. Sometimes it won't recognize the GoToMeeting won't recognize properly the audio device. Okay. Okay. Yeah. So just reconnect. It will resolve. Yeah. So I will just go through the agenda. In the meantime, those guys can rejoin. So we will see today what is the distributed system basically, and the need for the new generation of distributed systems, and what is a Spark, Apache Spark. Before that, Hadoop came, and many data warehousing tools which are working on the distributed systems came. So how it is completely different from them, and where a Hadoop is excelling, still it is a major force, and where Spark is excelling. So it is a new kid on the block. So we will go through all those things, and in the end, why we have to use the Spark, and which major companies are using Spark, and after that we will see what we will cover as part of the Spark. So that is today's agenda. Okay. So if we can see the distributed systems, we can see at 3 levels: the first generation, second generation, third generation. So the distributed system, the basically what is distributed system? Just some of for some of the guys I want to explain here. So a distributed system is simply similar to we do work in distributed manner by sharing the work among the teams, and then we will collaborate together and complete the work. So similarly, for the systems, for the servers, for that sake, so until 2000, servers are working on standalone. So the size of the standalone servers means one or two big servers with very good configurations. They do the work of um, for say 1 million customers. So and this has worked for very many people, but after certain limit, when everybody started using internet and everybody started using globalization effect and everyone, then this server's capacity is not okay. uh, Servers capacities are not up to the one second, just okay. So are not up to the mark. So they come up together as a clusters and other things, but that also didn't work. So then there comes the distributed systems. So there will be multiple systems. It can be 10 to hundreds or thousands, or even it can go up to 2000. A small servers, you can say we call it as a commodity hardware, and together work as a single server, work as a single system which can serve all of these. So that is what the distributed system means. So instead of a big single server, we are using multiple small servers to get work done. So in these distributed systems, Hadoop and Spark are the major forces right now. So what came in the first generation? Okay. So in the first generation of distributed systems, we have these things. Okay. So Teradata and Netezza and also HP Vertica is there, and even many other data warehousing tools has made their particular servers as a parallelized. So working in parallelized queries and other things. What is we are talking about all about data. So how to make the data working on data easier and faster and scalable. Okay. So for that only distributed systems came. So this is the first generation of distributed systems. So but these are costly and the world move on. So fault recovery is there, where they are proprietary, but they are doing good, but they are very costly. Everybody can't bear Teradata and Netezza kind of thing. So the next generation came as a open source. Hadoop is open source and commodity hardware, very cheap hardware. My software can work on any hardware, and distributed data. Data can be distributed. So one big file can be stored in multiple systems, which is very new at that point of time. And fault tolerance is no more like hardware thing. For the database administrators and system administrators, it is a big problem. Just a moment, guys. There is a disturbance from my end. Just a moment. I will mute and come back. Yes, guys. Actually, there was a huge disturbance. Yeah. So this is the second generation distributed systems. So these are in Hadoop. Okay. So many systems are there. So including HPCC and other systems. So this works on commodity hardware and software level fault tolerance. And there is something called block oriented structure. So whatever big file you give, I will divide into blocks, into fixed size blocks, and store and process. So this is the game changer for the Hadoop and other things. Okay. So commodity hardware is one of the game changer, and distributing the data used on the block oriented structure is also a major game changer, and fault tolerance is based on the software able to detect which of the copy is not working, where the data is unable to access. You just go there, and so the we say that is called replication of data. So 3 copies of data will be there at least. So and software knows where exactly it is. So no more it is hardware game. So everything is software based management. So because of this, Hadoop and other second generation softwares got very good success. So Hadoop is in fact one of the driving force right now. Okay, so why we need the new generation? So I hope here everybody is clear, because based on these techniques and because of these strengths only, even Spark is moving forward. It is open source. It can run on any of the hardware. It is distributing not just the process, how the Java process or any programming process, it also can distribute the data. And we can recover the data and fault recovery based on the software. And so these are the major forces which are running now. Because of these only Spark and Hadoop are able to achieve the goals. So why we need the new generation? And what we are achieved with the Hadoop is all data warehouse related data warehousing projects in one way or other way are using Hadoop. So to load shedding and completely moving into Hadoop or anyway, somewhere other way. So complete DWH projects are able to guys, even still if you people are facing some problems, I don't know, try to rejoin. I'm just giving you my mail ID. So is it clear now? My voice and content? Yes. Yeah. Okay. Thank you. So some of the guys, so I just gave my email ID and phone number. Just ping me later. Still, if you are facing the problem, because we are in the middle of the session, So sorry if you are unable to hear and see the screen. I will continue. You people can ping me afterwards. So yeah, so where data warehousing projects for high latency and these things already moving into the Hadoop. Many projects, many companies, the telecom domain and banking domain, healthcare. So many companies are already moving into the Hadoop in big way. But what are the problems? Do we just have the data warehousing kind of projects only in the industry? No. So we do have a lot of challenges. So a lot of data is coming, lot of big data, not just for the data warehousing, even for the online purposes. For example, it's a Sensex or something just like Sensex. We do want to analyze the scripts or particular company's prices on every 10 minutes. We want to predict as a company, and how we can't do that those things in just using the Hadoop. So, and we are unable to make certain, we are unable to make some of the changes. So big data, whatever is there, we are able to just do it from the online kind of thing. That means hardware and software changes, a lot of changes happen, especially in the RAM. RAM size has increased a lot for the servers. Not just for the servers, even in the mobiles, RAM has changed. It became very cheap. So when Hadoop came in 2005 and that time, RAM cost is very high. So it has used the disk as a primary storage and processing. And now we have a lot of RAM and SSD, so which we can make use of it. So for that sake, so to make the things faster, new architecture is required. A new use cases came where the output is required within a minutes or within a max hour, within an hour I need good output for the report and other things. So that is called online analytics. So for that we need to use the memory. In memory online analytics is the requirement, and also I need to do certain things in very fast way. For example, Facebook uses a lot of graph processing, and for that also Hadoop is not supporting very much, and which are iterative in nature, calculating the same thing again and again. So for that also in memory will be the best. So disk space is already cheap, and RAM is also became cheap. So and in 2000s it is not right what is right now. So RAM is very costly, but now it is network speeds also increased very drastically within the systems, and RAM also become very cheap, and multi-core systems came. So calculating in the memory and storing there is very good choice now. So for that sake only we need of Spark came. Okay, and another big difference is in 2000s everything is object orientation. What is right now? Everything is function oriented, functional programming languages. I think you people might heard at least one of the function programming languages, functional languages, especially Python is supporting fully functional, and Scala is fully functional, and there is something called Haskell and Clojure, and many other functional programming languages, they are on rise now. Because of this, we have uh, very good flexibility to write the things which are very complex in object-oriented languages in very easy way. Okay, so what is there in 2000s is this. Everything is object-oriented language, .NET, Java, .NET, and everything. And software is optimized only for single core machines. At that time, those are only famous. And there is no open source community very active like that, like now. And SQL, only SQL is the major data analytical tool. No NoSQL databases or even machine learning things like SAS and R programming and other things are not that much famous. So that is in 2000s. Now everything has changed, even in software. So everything is functional, and software has exploited the multiple cores of the machine, and open source community has created a lot of alternatives for storage, for processing, for the distributed systems, for the sake for the databases and other things. Okay, big data processing, how it has changed, and we know that big data is getting created everywhere. For example, Google itself processes terabytes of data on daily basis, which is using Hadoop kind of distributed system, which is Google file system and MapReduce. And when the volume is very big, we can do batch processing, but it takes a lot of time. Mostly used for the search engines, log analysis, data warehousing, and even for the recommendation engines at the back end. So for so many use cases. And what are the needs right now? Velocity is the main concern. So how velocity is the main concern? So data incoming speed increased drastically. So for example, if you take the Facebook, FB data generation speed, we can imagine it is TBs for every 1 hour. So in terms of terabytes of data, we are getting generated. The data is getting generated. And same thing for the YouTube or Android systems and many of the major companies. And so to manage that much velocity, the speed, we can't do that with the batch system. And also the real time, the purpose has also changed. We need to show everything in real time for the users. If we may give the data of yesterday, people are not liking it. So they want a near real time. Okay, half an hour wait is okay, 1 hour wait is okay, but not the yesterday's data. So that is why we just able to do these things. So I'm just going into introduction of the Spark, and by just telling the second generation shortcomings and how the Spark has started. Okay. So these are some of the shortcomings. Batch processing is not is major shortcoming for the new type of use cases, and there is tightly coupling between the API and runtime, and it is too complex, like MapReduce and other things. And just like we told, with the latest generation, they are able to exploit the RAM. They are able to exploit the multiple cores of the system, and they do have alternative storages, and they do work along with the NoSQL databases. That is the Apache Spark. So how Apache Spark has started and what is it exactly? Okay, so we might heard so many things about Apache Spark. So the what is simply Apache Spark is it is fast and general engine for large scale data processing which can do in memory. So I can say in single line, in memory online analytics analytical tool. Okay, it is an analytical tool for use data for faster results. So it is created by the AMPLab, and now a company called Databricks maintaining this, and it is completely written in Scala, and it is Apache project. So when Spark has started, how it has started? So Spark has started in 2009 as part of the University of California, Berkeley, which is the topmost university, one of the in the US, as a project to address the issues in Hadoop systems. So it is not at all competitor at the time it has started. So it is the issue to resolve the some of the issues of Hadoop system. They come up with something called Apache Spark. So along with the Apache Spark, they have created many other ecosystem tools. So what are their main challenges are iterative programs, interacting querying, very interactive. So it is not like running behind and we have to wait for 2-3 minutes minimum. So and unifying the real time and batch processing. So this is what the unifying means. So Apache Spark is there. It can work on the Hadoop. It can work on the NoSQL databases. It can work on Mesos, and we can do batch processing. We can do interactive processing. We can do streaming. We can do iterative programs. We can also do the graph processing and so on. These are some of the cases only on the top layer. We can do much more. So the machine learning we can do. We can do like graph ML, graph databases queries, whatever. So and list will go on. And now we are able to run the R programs also on top of Spark. So it is like a one platform. We can do multiple types of works. Why this particular? What is unification and why we need a unification? Simply, unification means is this. One platform or for all needs. So generally for SQL and for ETL purpose. So SQL query we need to do. So ETL like Pig or Informatica. So if one tool can give all these things, so machine learning, ML, if we want to do. So streaming applications. So if we can have one single tool for all these needs, then that is a unified force. So one single thing. So why it is matters is, as a developers will feel easier and even good for the users. The cost of the having it is very less, and even for the distributors like Cloudera and all, It's very easy to integrate everything into one single thing. Okay, so this is the unification means. Anybody who is having doubts, they can ping. So just like we were discussing, so as part of the unifying force, so what? So something is, should be happening in the behind. So single abstraction. So that is called RDD. So because of RDD only, we are able to do all the things in single tool called Spark. So what is RDD? It is simply one kind of a storage thing for data set for huge data in a distributed way in memory, or so it is a completely distributed data set, and also it is a resilient, so which is a fault tolerant. In one single line, if I want to redefine this RDD, I can say it is a data which is stored across the machines in a fault tolerant way, and it is abstracted by the file system. So whatever file systems you give it in my systems, I can happily store it because it is abstracted from the file system, and also I can recover back whenever I want, and I can do processing whenever I want. So that is what the RDD does. Okay, so it is independent of file systems, and it is also fault tolerant and distributed. Okay, because of this only Spark is working that much fastly. So majorly RDD stores in the memory based on the availability, and also need of the hour. If it is batch processing, then we can work that as a file based thing. Okay, so this is the major concept and major driving force for the Spark. So for example, if I want to do a simple application like spam detection, what kind of things we may do? So spam detection is very crucial for any mail server. So the data will be so many mails will be creating on every second. So it is a stream of data will be coming to the server. So first of all, I have to manage the streaming. We can make use of Spark streaming application, and then once the data comes as a RDD, which is a data inside the main memory or offline or wherever, but we can work on it seamlessly. So the output of the Spark stream is an RDD, and on top of it, we have to apply some algorithm. So by comparing with, so spam filters follow certain logic. For example, they will make use of the latest sensations, like Donald Trump is latest sensation. So they may make use of the latest sensational news, and make use of them, and also they may make use of free things. You got a free lottery or something. So based on that, we'll create a good algorithm, and that will go into the querying tool. And okay, detected, some of them are detected. Then I want to show them in an analytical way. How many, what kind of spams are coming, that kind of thing. I have to enable the Spark query language also, similar to the normal SQL. And then I have to store back in any another NoSQL database so that my reporting tools work fine with this. So this is a small application where the Spark can easily manages. Okay, so streaming means continuous data is coming. So that could be a Facebook like social media application or search engine, or it can be a Flipkart like e-commerce website and so on. So data will be coming continuously and very high speed. So we can do apply the machine learning and a SQL kind of thing, and at the end integration with the NoSQL databases. For example, MongoDB is one of them, and Cassandra is one of them, which are supporting fully Spark. Okay, so these are the four different APIs parts of Spark. So what are the advantages of Spark now? So we have gone through some of the things. What are the advantages? So it can run on anywhere, and anywhere means what? So it can run on the in your own machine without anything. Just simply we can download the Apache Spark, which is very small file, and run it on your own local file system. And you can work on Apache Mesos, one file system which came from the same institute. Okay. So before going into further, I will just show you the AMP Labs. Okay. So where Apache has started. So this is the AMP Lab project. So what they have as a software is this one. I think everybody it is visible to everyone. So as part of this Apache Spark series, they have developed this many applications. So this is the lowest level file system, Apache Mesos, and so many. Here it is Apache Spark. So this is the ecosystem of Hadoop. So some of them are in development, like BlinkDB and other things, but most of them are work completed. So Spark streaming is here, and machine learning and all other things. So this is AmpLabs is part of the Berkeley University, and they have developed majority of the Spark tools. Okay, so this is the what they call it. This is called data analytical stack for Berkeley. So anybody can go through it. Interested people, I'm just thinking here later on also. Yeah. So it is very good source of data, and other things are available here. If you just click on them, we can go to the Spark. For example, Spark itself. I'm just opening it. So this is a Spark page. So directly you can go and go through some of them. So what libraries are there? So just like we gone through, there is a SQL library, there is streaming applications, there is machine learning and graph databases. These are the major things which are provided by the Spark. Okay, I'm just coming back to our. Okay, so that is a small thing about Spark. So what are the major advantages of Spark? So it can run on anywhere. So just like we have seen there, Mesos is one of them, and HDFS it is supporting. So it can work on any Hadoop thing, and it can run on your own machine. And second most important thing, it is open source anyway. That advantage is there, and other advantages, it is very just 1600s of code. That is for the core of Spark, and now including with other projects, it can go beyond. but initial versions has only 1600 lines. Now improved and given support to so many uh, tools, so the lines of code might increase to double, but still it is very less code. The source code is very less in compared with the MapReduce and other tools. So how it is achieved? Because of the single thing, that is functional programming. So with the functional program, which is a concise, so concise and clear. So it will be in the mathematical in nature. So because of that, we can represent any formula or any mathematical kind of computations in very precise and concise way of doing it. In simply 2 lines or 3 lines, I can calculate a very like matrices and other matrix multiplications and finding out the inverses and that means complex operations also. I can do it in very easy way and in very short code. So that is small and simple. You can just go through the source code online also if you have some time. It is very less. Just have a look at it. And now we will compare with Hadoop. What is there in Hadoop and what is the purpose of each and how they have implemented in Spark. So we have Hadoop and Spark. So just have a glance. I'm just comparing it in the notepad with a little more info. And after this, we'll go through the what we cover in detail and how much time it may take. So we'll compare with Hadoop and how it is much more advanced in a sense. So first is core, which is Hadoop. It has HDFS plus MapReduce, and it is Spark. Any file system, because just we have seen it runs on any file system, and Spark core. So which is a kind of RDDs and transformations. So I'll just give a small info about that. So here HDFS is a file system in Hadoop. So it won't support any other file system. And we have a processing system called MapReduce, and which can do many things, and also it has its own limitations. It can't do every kind of transformation. And what Spark does? Spark supports any file system. That means limitation of single file system gone. And Spark supports a something called RDD, which can work on any file system. So, and here it is not there. So in that way it is advanced. And second thing is transformations. In MapReduce programs, we can do only two type of things, that is map and reduce and sort and shuffle. Very few limited types of transformations we can do. And in Spark, we have a huge number of transformations. For example, along with the map and reduce, we have filter, we have reduce by key, and we have different type of joins and so on. So it is supporting huge number of filters are transformations. So which is not there in the MapReduce. So this is about the core, and next is supporting the SQL. So here how the Hadoop is supporting SQL. So it is supporting SQL through Hive, and Spark is supporting through Spark SQL. So how they are different? So Hive, so SQL queries for batch, in the sense it is mainly for data warehousing, and on HDFS and MapReduce. So on Hadoop only. Yeah. So basically this is the Hive. So advantages are there. It is very fast for the batch processing jobs, but interactive is not there, and it cannot work. It can't work with other databases like NoSQL databases. And what is there with the Spark query language? Okay. So Spark query language does this. So it supports, like we have seen, it works on Spark core, and it supports the interactive queries. And it supports multiple databases, NoSQL databases especially. As part of that, it is also supports Hive as a data source. So that means a Hive is there, and on top of it I can run the query language, Spark SQL. So it is not specific to one particular database. So it has got more advantages than the Hive. Okay. So same thing for Mahout. So Mahout is a machine learning algorithm library inside the Hadoop, and mlib is a machine learning algorithm library in Spark. So basically both works on similar things, but the thing is that mlib is faster. And we have Impala. So a Hive or Impala, two tools we have. Uh, basically Impala is for interactive queries on Hadoop. But the advantage of Spark SQL is we can do in single tool both the things. For the batch processing queries also we can do, and also interactive queries. And Hive can't do interactive queries, Impala can't do batch processing. So when data is very huge, Impala will get so many problems. So Spark QL, the single thing, purposes are multiple. So similar way, we have processing of streams inside Hadoop ecosystem. So that is Storm is there. So Storm, it is a different tool, works on Hadoop. It is not native. So streaming is, whatever the Apache Spark streaming, it is native to Spark. So it is faster. So in the same way others, so up to the Impala which are native, but Giraffe and Storm are not native to Hadoop ecosystem. They work on top of the Hadoop as a tools, different tools working on top of it. And whereas GraphX and Spark Streaming are internal to the Spark. So whatever we have in the Spark side, all are Spark one single tool, multiple modules. If you want to use only Spark SQL, you can make use of single thing. If you want to use only machine learning, you can make use of it. These are different components of same tool. But whereas Hadoop, we not all are different. Everything is a different tool together, which works on top of Hadoop. So there the unifying force is not there in Hadoop. Okay. So this is small comparison of code size. Any doubts here? Just let me know, because this is the how Hadoop and Spark works. So we are going into concluding notes before saying the syllabus and how much time it may take. So what is the major single line advantage for this one is Spark can do in memory, and that's why speed directly on the memory data. Okay, so all these things are major advantages which we discussed until now. It is more better fault tolerant. Okay, and Spark analysis can be executed directly on in-memory data. Okay, and the other big advantage of Hadoop, Spark is it works with Hadoop. So it is just like this. We have already a hardware for cluster for Hadoop. You can run your own Hadoop jobs, and just Spark is a addition. So that means there is no need to invest single penny for hardware for any company. So it is a major good advantage. That's why integration with Hadoop has given very big advantage for Spark. So just like I was telling from the beginning, Spark is not a competitor to Hadoop. Spark is able to do certain kind of jobs easier. Okay. And what it supports, which languages it majorly supports is this. So it supports Scala, which is the native, and Java and Python, and also R language. Okay. So these are the major companies who are using Spark. So Yahoo, NASA, and Hive is big company, and Entity Data, Groupon, and LinkedIn is using. So and Facebook is using. So these are some of the companies. Okay. Any doubt, guys? So now I will just tell you what we cover as part of this. So we supporting all of these things, and Spark with Scala, Spark with Python. There will be different batches for the both. So the guys who prefer Python, they can join this, and they can join the Scala thing. And what will be the duration? So this is 30 hours for Spark, and those who want to go for the Hadoop, that is 50 hours. So those guys can ping me later. I will send the syllabus and other things. So and we have online weekdays and weekends. The mornings between 7 to 10 we'll have the batches. Okay, weekends also we have batches. Timings are depends, but at least 2 hours, 2 to 3 hours on weekends. And here it is 1.5 hour. Okay, so 90 minutes every day. And course duration is 1 month. In 1 month we are going to complete, and we will be going through the project and use cases. So multiple use cases for the every tool, and in the end we will have the project. Just to have a glimpse. Okay. So that is the thing. So further doubts, if anybody has, I'm just giving my mail ID and my number. Just contact me, all the interested guys. So any doubts, just ping me at any time. Yeah, sure. I will share this particular presentation and this one in WhatsApp group. Um, Most probably I will be sharing this particular video in YouTube. Okay. Yeah, that's it, guys. Thank you for coming for the demo. Okay. Hope it gives you enough information about Berkeley, AMP Labs initiative, Spark. So you people can go through so many things. I will be sharing some of the good materials on group. So those who want to learn self-learning also, they can achieve that. You people has to spend little more time. Those who want guidance, they can come back to me. Okay. So AMP Labs itself is giving good sources, and yeah, as part of the some courses, Coursera, and so much information is there. But very be clear. Follow the only standard materials. Don't follow here and there. I'll be sharing the standard materials only. So that is just a small suggestion from me. Don't follow anybody's blogs or anything for learning. At least if you learn already, you can study anything, but for initial things, just follow from the standard universities and from uh, from the creators themselves. Okay, so that is my suggestion. Those who want to learn newly, those who want to learn Hadoop and Spark together, are just starting with the Hadoop. I will be conducting another demo in the evening, which will be more informative about Hadoop. I will be sharing my link online in WhatsApp after some time. They can join in the night. Okay. Those who are interested in specifically for Hadoop, they can ping me. Okay. Thank you, guys.